All right, folks, I'll just get started. My name is Daniel Rizk, and today I'm going to be talking to you right now about TidierDB, and at 2:30 I'll talk to you guys about TidierDB.jl. And so I'll just jump right in. A little bit about me. I'm currently an internal medicine resident at the University of Maryland. If you don't really understand that, I get it. Basically, it means I work like 65 to 75 hours a week in the hospital doing inpatient medicine. I first got interested in coding when I took Karandeep Singh's class back in 2023, the keynote speaker, where I met him when I was in medical school. In any case, let's just jump right in. So TidierDB converts tidier code to SQL, okay? And so Dataframes.jl, they're both wonderful, TidierData, excuse me, they're both wonderful kind of packages, but if you're working with data sets that are, 50 gigabytes of compressed data, or possibly that live on a database, you'll kind of run into some friction where you may have to use SQL. And not everybody knows how to write SQL, and so this package tries to address that. So you get one syntax for both data frames and databases. So to jump right in, let's say you have this patient, this data frame, and you want to see if you group it by people that are still alive, so that's the vital status, what is their mean expense in healthcare in the thousands, right? And this is, relatively straightforward. We're going to group by this kind of new variable we're making with this if, else, missing, and then we'll get the mean before arranging it, right? And what does the SQL look like for that, right? And so if you're familiar with SQL, this is pretty straightforward. It's just like a single kind of unit. You're going to select it, make your case when, and kind of, finish the necessary SQL to get that. And while that's really accessible, I think a lot of people, that may be a friction point for them, or if they're doing, much more complex data manipulations, that could be an issue. So this is what TidierDB looks like, and you can see that it actually is exactly the same with the caveat here, the aside show query lets us see the query, and collect is executing it. So you're turning that SQL query, you're running it, and you're bringing it in as a data frame. So you can do further manipulation with it. Brief history, 2013-14, dbplyr came out, and that converts dplyr code, or TidR code, to SQL, excuse me. Python came out 2015, it's the same exact thing, inspired by dbplyr. Rust has a version, now we have one in Julia, among kind of a couple other packages. So how do we go from the tidier syntax to SQL? So we have our database that's connected, great. And then next up, we have to get the metadata from the table, right? So we're not actually reading in the table here. All we're doing is grabbing the column names. DuckDB is our default backend. That means that we can use, paths, URLs, table names, kind of whatever you need. I tried to make it very broad. And then it's going to be executed and turned to SQL. So here we're seeing that second step right here. This is what the actual metadata looks like. It's a data frame. You have column names, types, and table names. And then over here you have the functions that underlie it, right? So for every single backend, there's a a parsing function, that will basically traverse the abstract syntax tree using macro tools and kind of turn this tidier code into SQL. And then eventually, you kind of get this lazy query construction. This example here is like a little bit inorganic, but it's just kind of for the sake of this example, or for this presentation. But like if we have empty cars, we want to group it by cylinder and then kind of see across the MPG, what's the mean, minimum, maximum, how many cars are in each group. Make some new categorical variable. We can kind of do all that, and you can see here what the query looks like. And then if you had a second query, again, it's inorganic. You make the second query, you're kind of doing it, you see the code, and then ultimately you can join these two queries together, and you can even join 6, 7, 8 queries together to make your final query, and then you collect it, right? So recently, for example, I had to write a function that worked on multiple tables on a database that was about 50 gigabytes of compressed text data, and it works, right? So I wanted to stress too that I wanted to bring the best of SQL and tidier together. This is a chaotic slide, but so on this side right here, you're seeing all the top-level macros we have, and then here's the other tidier kind of package functions that it supports. But also, it comes out of the box with support for every SQL aggregate function and every SQL function that exists, as well as window function and user-defined functions, right? SQL's been around for 30 years, 40 years. They have excellent gems that I want to make sure were included. So this is an example using kind of the pre-existing kurtosis function. You can see that we can calculate the kurtosis in this table without doing any additional work because it recognizes that function. We can essentially push this to the aggregate function list that is kind of stored within it. And again, you can see the exact same thing. You can now do this in a mutate call, which is not aggregated. This is like the nuance of SQL that I want people to be able to avoid if they don't have the time to learn it. User-defined functions, here we're just making a quick binomial, or like we're gonna multiply them, and then we'll kind of push that to DuckDB. You can do it, you multiply it, that's nice. So you can see here it's immediately recognized. And then if you change the function, now you have a plus b times a minus b, and you redo it again, it's already updated, okay? This is just a quick example of leveraging pre-existing SQL, not only functions, but SQL syntax. So for example, DuckDB is my favorite of all the SQL backends. They do excellent work. They have the ability to dot chain functions together. TidierDB supports that. So if you want to dot chain your functions like you would in DuckDB, you can still do that. Here we're going to take the model, and then we are going to make it uppercase. We're going to split it. We're going to aggregate it. We're going to concatenate it. It will do all of that. And then we want to select if it starts with model, and then there are your 2 columns. We're going to grab the first 6 rows. So that was kind of a whirlwind, but thank you to kind of R&D. He iterated with me and brainstormed, Vittori and Mose, and this guy on GitHub who's helped me find a lot of edge cases. Thank you.